So hey fellas, this is your professor, and in the previous videos we saw about the observations we get from a chemical reaction, and in the next video we saw the balancing. I was getting many requests that my board wasn't visible, so I have changed the angle today. And today we'll study types of chemical reactions. So let's start. The first one is your combination. The second one is your decomposition. The third one is displacement or replacement. And there is one more which we will see later, or we can write it somewhere like this. So this is your second, this is your third, and your fourth is double displacement. So these are the four types of reactions which we will study: combination, decomposition, displacement or replacement, and then double displacement or double replacement, we can say. So let's start them one by one. Okay. The first one, combination. So from the word you can get that we are combining something. So let's say if you have two things and you combine it, how many things you have now? You can see this is a whole one thing. So that is combination. I will first write the general equation. So if you have two reactants, let's say A plus B, and we get one product. So when two, or it could be more than two, or when two or more, we'll not say things because we are not combining things in chemistry, we are combining reactants to give a single product is known as combination reaction. The first example is of quicklime. So CaO is your quick lime. When it is mixed in water, we get slack lime, that is calcium hydroxide. This is slacked lime. Also, one more thing to remember, most of the combination reactions are exothermic in nature. So this triangle shows heat is released. So what is the name of such reactions where heat is released? It is known as exothermic reaction. So another example, this was example number 1. Example 2 will make it much clearer for you. So when carbon is burned, so burning takes place in the presence of oxygen, we get CO2. When wood logs are burnt, why they are burnt? To get heat. So when heat is written on this side, it shows what kind of reaction it is: exothermic reaction. So most of the combination reactions are exothermic in nature. So this is the first type of chemical reaction. Let's see the second one now. I hope it was clear. You can pause the video to write the important things, important reactions. Let's see the second one. Second one is your decomposition. So decomposition. So you know what earthworms do, right? They decompose the substance, whatever is present in the soil. So decomposition means they break down something. So we will have, this is just the opposite of combination. Here we have one reactant which is broken down into many products. Let me write the general equation. So let's say you had AB as your reactant and it is broken down into A plus B. Here triangle sign is written over here. So this triangle here means that heat is absorbed. So where heat is absorbed, it is known as endothermic. So thermic is related to heat again, and endo means absorption, exo means releasing. So most of the decomposition reactions are endothermic in nature. So let me write the definition. When a single reactant breaks down into simpler products, that is your decomposition. First example will be of calcium carbonate. So this is the formula of marble also, keep it in mind. When we heat it, we get CaO plus CO2. This is a gas. We can also show it by upward arrow. So this is a decomposition reaction. Another example we could take of FeSO4. When we heat it, we get Fe2O3 plus SO2 gas plus SO3 gas. This is the second example. Also, this reaction, decomposition reaction, can be of three types again. So where we have this triangle symbol, that is your thermal energy. So these are based on, this is your thermal decomposition reaction, thermal decomposition. We can also have electrolytic decomposition. Electrolytic is related to giving electricity. We have one example, and that is also given in your activities, which is the breaking down of water into hydrogen gas and oxygen gas. That takes place in International Space Station also. That is how they get oxygen, by breaking down water. So I am writing the balanced equation. 2H2O gives me 2H2 gas plus oxygen gas. Remember, this is produced at the cathode, because cathode is negatively charged and hydrogen has plus charge. That's why plus will be attracted towards the negative. And anode, where oxygen is produced. As you know, oxygen carries a negative charge, so it will be produced at the positive terminal of the system. So this is your electrolytic decomposition. The third one is your photolytic decomposition. You sit like this. Photolytic decomposition. So here heat is given in the form of light. The best example is AgCl. So for light we use Hν. Okay. We get 2Ag solid plus chlorine gas. So what happens is, if you have AgCl in your hand and sunlight falls on this, all the chlorine gas evaporates and we are left with this silver. So yes, these are the three types of decomposition reaction based on the energy which we are giving. So first one is normal heating. The second one is electricity. You can write electricity over here like this. And third one where sunlight is given. So photo is related to sunlight. So you know photosynthesis, that also happens in the presence of sunlight. So yes, photolytic decomposition, electrolytic decomposition and thermal decomposition. These are the three types of decomposition reaction. Also remember, this one is used in black and white photography. Black and white photography. So remember, this is the application of this reaction. You have one more example, that is AgBr. That will also go with the similar manner like this one. So yeah, this is the second type of reaction which we just saw. Decomposition reactions are endothermic in nature, and the three types of reactions. There are more reactions. You can go through it by yourself, and if you want any explanation for that, we can get back later with another video. The third type of reaction which we will see now, let me rub it first, then I will tell. The third type of chemical reaction is your displacement, or you can say replacement. Somewhere they call it replacement, somewhere they call it displacement, like that. So for this reaction, let me give you a very good example. Let's say there are two kings who are fighting, right? One will be more powerful and the one will be less powerful. So what will happen? The more powerful king will come and remove this less powerful king, and he will take his throne. So that is how these also work. So if you have AB, which will be in aqueous form, and you put a C element, which is usually, this is usually metals. So what will happen if this is less reactive or less powerful, right? Because we have to use reactive word. If this is less reactive and this is more reactive, what will happen? This will happen. This will come in aqueous form and this will go in solid form. So this is the third type of reaction. Let me put up an example. Yes. So these are based on reactivity series, which will come in later chapters, which we will see. So first, let's write the definition. So when a more reactive metal displaces a less reactive metal, or you can write element also, that would be fine for now, but this is usually for metals only, but for this chapter it is element, so I'm writing it as element. When a more reactive metal displaces a less reactive metal from its aqueous, I hope you remember the word aqueous, solution. So this is the reaction, definition of the reaction. The reaction which I am giving now, so Fe solid, this is an activity in the NCERT book as well. You can refer the activity, because nowadays you are getting diagram based question as well. The paper pattern of the paper has been changing lately. So yeah, Fe is more reactive, iron is more reactive than copper. So what will happen? You know, change of places, right? So we will get FeSO4 aqueous plus Cu solid. This is the first example. We can take another example. So Pb solid plus CuCl2 aqueous. Again, Pb is more reactive than copper. Again, change of places. So we will get PbCl2 aqueous plus copper as solid. So this is the third type of reaction which we just saw, that is displacement or replacement reaction. I hope it is clear. Let's see the last reaction, the last type of reaction, chemical reaction, is your double displacement, or you can say double replacement if you want, but let's use the word double displacement. So here it is double displacement. So we will have AB plus CD. So if I break them into ions, what will happen? Just remember, we always write the positive part first, then we have the negative. You will get to know it in the coming chapters. So this will be broken down as A plus, B minus. This one will be broken down as C plus, and this will be broken down as D minus. So as I said, double displacement. So this positive will be going with this one, and we will get AD. And this positive will be going with this minus, and we will get CB. And here, some of the reactions, you can get a downward arrow. And I hope you know what does that mean, that we have a solid. So if we have an insoluble substance, as we are having it here, it is also known as precipitate. And such reactions are known as such reactions where insoluble substance is formed, or such reactions where a precipitate is formed. We call them as precipitation reaction. Not all of them are precipitation reaction, as I said, but most of them. I will give both the examples, don't worry. So let's take an example of an activity. We have lead nitrate and potassium iodide. So lead nitrate, so PbNO3, so lead is +2. Okay. This will be in aqueous form, and potassium iodide is Ki, that is also in aqueous form. So what will happen? Exchange of ions. This K will be coming with this Pb will going with this. Just remember how you have to make the product. That is more important. So we will get PbI2 as a solid here. Remember the color. It is of which color? Yellow. And the second one is KNO3, which will be in aqueous form. So here a solid is getting formed. That is why it is also known as precipitation reaction. One more example where precipitate is not formed, still it is a double displacement. That is HCl plus NaOH gives me NaCl plus water. So here it is not in solid form, everything is in mixed form. This is another example of precipitation, not precipitation, double displacement. Here we don't have the precipitate forming, right? So as I said, most of the reactions you will find a precipitate which are related to double displacement. But yes, some of them where you don't get a precipitate. Here all are in aqueous form, or we have liquid, no solid. Even though it is a double displacement, right? Na is coming with Cl, H is going with OH, that gives me water, Na plus Cl gives me the salt, right? This was the 4 type of reaction. I hope I was very much clear and the lightning was good today. If you have any comments, the professor is here. Comment in the chat if you want in Hindi. I can explain in Hindi also. I think my English is slow and I am telling you with all the details. It's better to learn in English rather than going in Hindi. So it's up to you. If you want me to tell in Hindi, I can do that. But for now, taking adieu, tata, bye bye.